And we're live. Okay.
Welcome back to Mr.
All right.
Bonnet.
All right, here we go. All right. So I'm teaching about linear inequalities. So in the same conversation of like a system of equations, you could have a system of inequalities, but let's first go over how to graph linear inequalities. Okay? So you don't have to solve these. It's not like I'm asking you to use substitution or elimination. I just want you to graph it, and you're going to show visually what the solution looks like. Okay. So you guys have seen the equation, for instance, y equals, let's just say, 2x minus 2. Let's use that as our sample equation. And hopefully by now you guys are all really good at graphing this. You know to put a graph down. You know to start with your y-intercept, which is at -1, -2. And then you know to follow the slope. So that's up 2 over 1. Up 2 over 1 again. Let's just do it twice. Get a smooth line in there. Relatively smooth, maybe. Okay? So you guys know how to do that. So if you know how to do that, then this part of the test should be the easy points for you. Okay? But the thing is this an inequality? It's not an inequality. You know how I can make it an inequality? Whoa. Did you guys even think that was possible? Have you seen this before?
Yeah.
So now instead of just graphing the line, and actually let's make it greater than or equal to for the purposes of this problem. I'm actually going to shade. I'm going to shade part of the graph. I'm actually going to shade part of the graph that's kind of what this line identifies, either above it or below it. Do you think based off y is greater than 2x minus 2, should I shade above the line or below the line? What makes more sense to you? Above, because it's greater. So then you shade the region above the line, and that represents y is greater than 2x minus 2. Okay, so that's the concept. That's the start of the concept. Has anyone learned this in the past?
Yeah.
Okay. All right. Some of us have. A handful. Okay. All right, so I'm going to move to the right side of the board now so it can kind of take it to the level that we needed at for the lesson. This actually might be a really short lesson. If you guys know how to do that, that's great. Okay. Another situation. All right, same type of problem. Y is less than 1/3 x plus 1. Okay? Would you guys be able to graph that? I'll give you a second. Try to do it on your own papers. I'm just going to erase this left side of the board right now. And if you're watching this video later, hopefully you're trying to graph that too. Y is less than. Okay? But I want you to keep in mind one thing. Because it's less than and not less than or equal to, remember how if it's on a number line, there's a difference between an open circle and a closed circle? What's the equivalence here? It's the difference between a solid line and a dashed line. Okay? So plus 1 and then 1/3 x, so it's up 1 over 3, something like this. And then instead of making a solid line, because it's not equal to it, it's only less than it. So how do I show that it's not equal to that line and only less than the line? You make a dashed line instead of a solid line. That's how you do the difference between less than or equal to or just less than. And then again, the thought process is, do I graph above the line or below the line?
Below.
Below. Below is correct, and then you shade below the line. Oh, you guys are really good at this. Okay, cool. All right. Well, the final thing I have to teach you, since that all makes sense, is when you have a system of inequalities. Meaning you have two inequality equations. Y is greater than 4x minus 6, and y is less than -2x plus 10. I'm trying to make these equations a little bit far apart from each other and look very different. Now, because it's a system of because it is a system of inequalities, it's not just going to have, you're not just looking for, you will do the shading, but you're looking for the shaded region in common, okay? Which is why I brought these colors out with me so we can kind of see that illustration. So let's start by graphing these equations. So 4x minus 6, 1, 2, 3, 4, 5, 6. Okay, and up 4 over 1, so it looks something like this. And we got a line that looks something like that. And it's because it's actually not equal to, we gotta make a dash line, almost forgot that part. Dash line, okay? And we're gonna be shading above it, so let's go ahead and do that. Okay? This is not my solution, this is just the work to get to the solution, but you'll see it in a second, it'll be very obvious. Alright, and y is less than negative 2x plus 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, somewhere out here. And then negative 2x down to over 1. It's probably something like this, except it's dashed again. Just made it solid by accident. Alright. And it looks like it's less than it, so I'm going to shade everything less than that line, which is, okay, this is below it, and that's above it, right? Okay. And then we're looking for the shaded region in common. That's our solution. So on the test, I'm actually going to ask you to maybe box that region or kind of identify it, that it's just, it goes from here, here, and then it's all this. So this is the region I'm looking for. I don't care about this anymore. That's not in common. And I don't care about that anymore. That's not in common. There's just blue there, and there was just red down here. I want the blue-red region, okay? Because that's how I showed the system for that linear inequality. That's the solution for that system. It's a visual thing. You graph it, you show what it looks like, you indicate what it is. I'm going to notice this the very dark green. Like when you get your solution, even if there's red lines here and blue lines here or whatever pencil colors, definitely make sure you highlight this as dark as possible, so I know what your solution is. It's not down here, it's not up there, it's not over there. It's very clear it's up in here. Okay? All right, that's my whole lesson for today, actually. Okay, you're gonna have some homework on that. You guys can get started now.